Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping back into an 8th grade topic, geometric dilations. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. At the end of this video, I'll be linking my 8th grade playlist in which I cover a ton more topics. So if you're interested in that, make sure you stay tuned. As always, if you have any questions about what we see today, or even your own homework, you can always put in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. Today's video is going to have 3 parts, so leave a like, smash subscribe, and let's get started. In our previous video, we talked about dilations centered at the origin. And because we were centered at the origin, we had a wonderful shortcut that we could take advantage of. However, that wonderful shortcut is not going to play out here. That shortcut was afforded to us because we were centered at the origin. And now that we're going to be covering dilations not centered at the origin in this week's video, we do not have that luxury. Now, if you have no idea what I'm talking about, if you haven't seen my first video on dilations, no worries, I have it right up here. You can check it out at any time. However, there was a shortcut in which all you had to do was apply your scale factor to each and every point, and that is how you're going to find your geometric dilation. But before we can talk about why that won't work for dilations not centered at the origin, let's first talk about why it did work for those dilations centered at the origin. Let's say we had the triangle ABC with these 3 points, and we have a dilation that's centered at the origin with a scale factor of 2. We found out that all we had to do was multiply each and every point by this scale factor, and if we would do that, we would get an A prime, B prime, and C prime that looks like this. -4, 0, 4, 0, and 0, 4. All we have to do is multiply this scale factor by the x and y component of each point. And if you were to graph it, you would get something like this. Now, if you look at this A prime, C prime, B prime triangle here, it does in fact look like you've pretty much made this bigger by a scale of 2 if you look at the points. But the reason why this worked is because we were centered at the origin. Notice, whenever you're centered at the origin, the points of your original graph is the exact distance away from the origin. So if you want them to be twice as far, scale factor of 2, all you do is multiply your distance away from the origin by your scale factor. And by doing so, you get a point that's twice as far. The same thing works if you have something between 0 and 1. If, let's say, you want it half as far, you would take the distance it currently is from the origin, multiply by half, and now you've halved the distance. This is why it works so well whenever you're at the origin. However, this is also the reason why it's not going to work whenever you're not centered at the origin. Whenever we're not centered at the origin, it breaks down very quickly whenever we try to apply the same logic. So let's look at just one simple point, and you'll see what I mean by that. Let's look at point A. We have the same triangle ABC. This is A, this is B, and that's C. Well, we have the same exact triangle. However, we're going to be centered at the point 1, 0. So this is our new center. And we want to scale this triangle up by 2 when we're centered at 1, 0. Now the triangle doesn't have to be centered at 1, 0. We're talking about the dilation is centered at 1, 0. And that means that we want to find out how far each and every point is from this center. We can't just take this for granted now because this is not meaning the same thing. This is how far we are from the origin, 0, 0, but not 1, 0. A is going to be how far away from 1, 0. Now A is -3, 0 away from 1, 0. So if we want to scale this up, now we can multiply by 2, right? And it becomes -6, 0, right? After we apply the scale factor to the actual distance. However, that's not applying the scale factor to our point here. So we have a new point all the way out here at -6, 0. So that's 1, 2, 3 extra, -6, 0, and this becomes our A prime, which -6, 0 is definitely not 2 times this A. So you see, simply applying that shortcut that we found out in our last video, whenever we're not centered at the origin, is going to give us the wrong answer. So let's work on an example that has a scale factor greater than 1, and then another one that has a scale factor between 0 and 1, which both dilations are going to be centered at something other than the origin. So in this example, we have the triangle ABC, and we're supposed to be finding the geometric dilation with a scale factor of 2 centered at -2, 1. So this green point right here. So we don't have a shortcut. So the first thing we have to do is figure out what our ABC are and find out how far they are away from this point. So what are our points A, B, and C? So A is going to be what? A is 1, 2. So A is 1, 2. B is what? B is 2, 1, 2, 3, 4. So 2, 4. And C is going to be 1, 2, 3, -1. So 3, -1. And we're supposed to find out how far each of these points is going to be from this center point. So how far is A from this center point? Well, let's start from the center and go towards A. So the center is going to be, in order to get to A, we need to go up 1, and then we're going to go over 1, 2, 3. So we went up 1 and over 3. So those are both positive, right? So that means we're going to be going over 3 and up 1. So this is the distance. So I'm just going to put like a D here. That's the distance away from the center point. Let's do the same thing for B. If we start in the center and we're trying to get to B, how far are we going? So we have to go over 1, 2, 3, 4, and we go up 1, 2, 3. So we went over 4, up 3. So that's our distance. How about the C point? Well, we're going to start here, and we're going to go over 1, 2, 3, 4, 5, and go down 1, 2. So we went over 5 and down 2. So it's going to be a negative now. We went down 2. So these are 3 distances. Now we want to have a scale factor of 2, meaning we want to double these distances. So all you have to do now is multiply each one of these distances by the scale factor, or simply go twice as far for each one of these distances. Let me show you what I mean. So if we want to go twice as far for A, let's use a different color here. If we want to go twice as far for A, instead of stopping at 3, 1, let's go twice as far. So we're going to go to 3, 1, 2, 3, and then do another 3. 1, 2, 3. And we want to go up 1, 1, but then double that. So go up 1 again, 1 again. So we're going to end up right here. So this is going to be our A prime. We can do the same thing for this distance, 4, 3. Starting at the center point, we're going to go 4, 1, 2, 3, 4, and then do another 4. 1, 2, 3, 4. And then we're going to go up 3, 1, 2, 3, and then go up another 3. 1, 2, 3. So right around here somewhere. And this is going to be our B prime. And we're going to do the same thing for this C distance. Notice we're not looking at the point now. We're finding the distance, and we're working from that distance starting at our center point. So we're going to go over 5. 1, 2, 3, 4, 5. And then we're going to go another 5. 1, 2, 3, 4, 5. And then we're going to go down 2. 1, 2. But we're going to do it again. Remember, we're going to go twice as far. 1, 2. So right around here. And this is going to be our C prime. So we're going to connect these dots and see what our dilated graph is going to look like. So we graphed it, but I realized we don't actually have what our points are. So let's write down what A prime, B prime, and C prime actually ended up being. And we'll see that it isn't simply doubling these points. So A prime is going to be 1, 2, 3, 4, 1, 2, 3. So 4, 3. B prime was 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So 6, 7, right? 1, 2, 3, 4, 5, 6, 7. And C prime is going to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So 8, -3. So you see, once again, our points tell us we can't simply apply our scale factor to our original points in order to get our dilation when we're not centered at the origin. And if you look at this dilated graph and ignore the differences in how it's supposed to look because of how I drew it, you will see that it's staying true to what we think about dilations when you have a scale factor greater than 1. It should be getting bigger, and this graph is indeed bigger than our original. So it seems like what we knew about dilations is still true. It's just that we're no longer centered at the origin. So let's do one more quick example in which we have a scale factor that's between 0 and 1 and make sure that it still acts the same way we expect. In this last example, we have the triangle ABC, and we're going to be performing a geometric dilation with a scale factor of 0.5 that is centered at the point 3, -3, this green point right here. I've already written out our point A, B, and C, so all we have to do is find the distance from this center to each one of these points and then apply our scale factor to that distance. If we do that, that's when we'll have our geometric dilation. We do not apply the scale factor to the points directly. Remember, we're not centered at the origin. So let's first find our A distance. I'm going to call this AD for a distance. And in order to find our distance from this center point to A, all we have to do is subtract the 2 points. So if we're starting at the center and we're going to A is our final point. So we can do A minus the center, which is going to be this -3 minus that 3, right? So what's -3 minus 3? Well, that's going to give us a -6. And what's going to be this 1 minus a -3? Well, that minus a negative makes it a positive. So 1 minus a -3 gives us 1 plus 3, right? That double negative cancels out. So what's 1 plus 3? 4. So once again, all we're doing is A minus the center. We're trying to find the distance from the center to A. So we're going to do A minus the center. We're going to do the same thing for B distance. B distance is going to be B minus the center. So what's 7 minus 3? Well, that's going to be 4. And what's 3 minus a -3? Once again, that minus a negative is going to cancel out that negative. So 3 minus a -3 gives us a 3 plus 3. So this is going to be 6. And you can always double check this work by simply counting it out. You can always do it the long way and make sure you understand what we're doing. What is that C distance? So 3 minus 3 is going to be 0. And here we have -7 minus a -3. What's -7 minus -3? Well, once again, that double negative makes this a positive 3. So it's going to be -7 plus 3. So this is going to be a -4. So now that we found the distance from our center point to A, B, and C, we want to find the distance that our A prime, B prime, and C prime will be once we apply this scale factor to these distances. So we're going to call that A prime D, B prime D, and C prime D. A prime D is going to be the distance from the center A prime is. B prime D is going to be the distance from the center B prime is, and C prime D is going to be the distance from the center C prime is. So what do you get when you halve this -6? Well, -6, half of that is going to be a -3. How about half of 4? 2. Half of 4? 2. Half of 6? 3. Half of 0? 0. And half of -4? -2. So now that we found the distance that our A prime, B prime, and C prime are going to be from our center point, let's add these back to our center to figure out what our A prime, B prime, and C prime actually are. Well, A prime is going to be what? If you were to add this distance to the center, you're going to cancel out that X, so you're going to be at 0, and you're going to have a -1. How about this B prime? If you were to add this B prime to the center, you're going to be at 5, 0. And this C prime if you were to add that to the center, you're going to be at 3, -5. So let's plot all these points and see what it looks like. In which this is A prime, this is going to be B prime, and this is C prime. So you can see we started at A, B, C here, and we ended up at A prime, B prime, and C prime here. However, this is not just multiplying your scale factor by your original points. Don't fall into that trap if you're not centered at the origin. So I hope you're following today's examples. I hope you see that although we had that wonderful shortcut when we're centered at the origin, there's a few more steps when we're not centered at the origin. But if you have any questions on what you saw today, or if you're on homework, you can always put in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found this video helpful. And if you found it helpful, so could someone else. So leave a like, hit the notification bell, smash the subscribe, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Sempai.